Hello everyone. And welcome back once again to another interesting video. In this video we will delve into the various aspects of a career in data science, examining the job opportunities, career paths, and the skills necessary to thrive in this dynamic field. So if you are ready, let's start today's video. In the era of big data, data science has emerged as a pivotal field driving decision-making processes across various industries. As businesses strive to extract valuable insights from vast datasets, the demand for skilled data scientists has skyrocketed. This video aims to explore the dynamic landscape of data science, detailing the job opportunities available, the required skills, and the promising career paths within this rapidly evolving field. The role of a data scientist. Data scientists play a crucial role in transforming raw data into actionable insights, driving strategic decision-making within organizations. Their responsibilities encompass a wide array of tasks, from data collection and cleaning to building predictive models and communicating findings to stakeholders. The key functions of a data scientist include 1. Data collection and cleaning. Data scientists are tasked with collecting relevant data from various sources and ensuring its quality. This involves cleaning and pre-processing data to eliminate inconsistencies and inaccuracies. 2. Exploratory data analysis, EDA. EDA involves analyzing and visualizing data to understand patterns, trends, and anomalies. Data scientists use statistical techniques and visualization tools to gain insights from the data. 3. Machine learning model development. Building predictive models is a core aspect of data science. Data scientists leverage machine learning algorithms to develop models that can make predictions or classifications based on historical data. 4. Feature engineering. Data scientists often need to engineer new features or modify existing ones to improve the performance of machine learning models. This involves selecting, transforming, and creating variables to enhance the model's predictive power. 5. Model evaluation and optimization. After developing models, data scientists assess their performance using various metrics. They iteratively optimize models to achieve better results, ensuring that the models are accurate and robust. 6. Communication of results. Effectively communicating findings to non-technical stakeholders is essential. Data scientists should be able to translate complex analyses into actionable insights that drive business decisions. Job opportunities in data science. The field of data science offers a diverse range of job opportunities across industries. Some of the prominent roles include 1. Data scientist. As the primary role in data science, data scientists work on end-to-end data analysis, from data collection to model deployment. They collaborate with cross-functional teams to address business challenges and provide data-driven solutions. 2. Machine learning engineer. Specializing in machine learning, these professionals focus on developing and implementing machine learning models. They work on refining algorithms, improving model performance, and integrating models into production systems. 3. Data analyst. Data analysts primarily deal with exploring and visualizing data to extract insights. They may not engage in complex model development but are essential for providing actionable information to support decision-making. 4. Business intelligence, BI analyst. BI analysts focus on interpreting and visualizing business data to support strategic decisions. They often use tools like Tableau or Power BI to create dashboards and reports for stakeholders. 5. Data engineer. Data engineers are responsible for designing and maintaining the architecture that allows for the efficient processing and storage of large datasets. They build the infrastructure necessary for data generation, transformation, and analysis. 6. Statistician. Statisticians apply statistical methods to analyze data and draw meaningful conclusions. They play a vital role in designing experiments, conducting surveys, and providing statistical insights. 7. AI research scientist. In the realm of artificial intelligence, research scientists focus on developing cutting-edge algorithms and models. They contribute to advancing the field by exploring innovative approaches to problem-solving. Skills required for a career in data science. To excel in data science, individuals must possess a blend of technical and soft skills. The key skills include: 1. Programming skills. Proficiency in programming languages such as Python or R is crucial for data scientists. These languages are widely used for data manipulation, analysis, and machine learning. 2. Statistical knowledge. A strong foundation in statistics is essential for designing experiments, conducting hypothesis testing, and making informed decisions based on data. 3. Machine learning skills. Data scientists need a deep understanding of machine learning algorithms, including supervised and unsupervised learning. They should be adept at selecting and fine-tuning models for different tasks. 4. Data wrangling. Cleaning and pre-processing data are time-consuming yet critical tasks. Data scientists should be skilled in using tools like Pandas or SQL to handle and manipulate datasets. 5. Data visualization. Communicating findings effectively requires the ability to create compelling visualizations. Proficiency in tools like Matplotlib, Seaborn, or Tableau is valuable for conveying complex information in a digestible format. 6. Domain knowledge. Understanding the industry or domain in which a data scientist works is essential for contextualizing analyses and generating actionable insights. 7. Problem-solving skills. Data scientists need to approach problems with a logical and analytical mindset. The ability to break down complex issues into manageable components is crucial for success in this field. 8. Communication skills. Effectively communicating findings to both technical and non-technical stakeholders is vital. Data scientists must be able to articulate complex concepts in a way that is understandable to a diverse audience. Career paths and specializations. Data science offers a multitude of career paths and specializations, allowing professionals to tailor their careers to their interests and strengths. Some common career paths include: 1. Data science generalist. Generalists work on a broad range of tasks, from data collection to model deployment. This role is ideal for those who enjoy the variety and challenges associated with end-to-end data science. 2. Machine learning specialist. Specialists focus specifically on machine learning, diving deep into algorithm development, model optimization, and staying abreast of the latest advancements in the field. 3. Big data engineer. With the rise of big data, engineers specializing in big data technologies such as Apache Hadoop and Spark are in high demand. They design and maintain systems that handle massive volumes of data. 4. Natural language processing, NLP, specialist. Professionals in this specialization focus on understanding and processing human language, enabling machines to interact with and understand textual data. 5. Computer vision engineer. This specialization involves working with visual data, such as images and videos. Computer vision engineers develop algorithms for image recognition, object detection, and other visual tasks. 6. AI ethics and fairness advocate. As AI becomes more prevalent, there is a growing need for professionals who can ensure that AI systems are developed and deployed ethically and without bias. 7. Data science manager or director. Aspiring leaders can move into management roles where they oversee teams of data scientists, guide strategic decisions, and ensure the successful implementation of data-driven initiatives. Industry-specific applications. Data science has transformative applications across various industries, making it a versatile and sought-after skill set. Some industries that heavily rely on data science include: 1. Healthcare. In healthcare, data science is used for predictive analytics, personalized medicine, and improving patient outcomes. Analyzing electronic health records and medical imaging data are common applications. 2. Finance. In the financial sector, data science is applied for risk assessment, fraud detection, algorithmic trading, and customer segmentation. Predictive modeling helps in making informed investment decisions. 3. E-commerce. Personalized recommendations, demand forecasting, and fraud detection are key applications of data science in e-commerce. Companies leverage customer data to enhance user experience and optimize supply chain operations. 4. Technology. Data science is at the core of technological advancements, from developing recommendation systems for streaming services to optimizing algorithms for search engines and social media platforms. 5. Manufacturing. In manufacturing, data science is used for predictive maintenance, quality control, and supply chain optimization. Analyzing sensor data from machinery helps prevent breakdowns and improve efficiency. 6. Education. Educational institutions use data science for student performance analysis, personalized learning paths, and administrative optimization. Learning analytics contribute to enhancing the overall educational experience. 7. Government and public policy. Governments leverage data science for policy making, resource allocation, and public health initiatives. Analyzing census data, crime statistics, and social welfare data aids in informed decision-making. Challenges and future trends. While data science offers immense opportunities, it also comes with challenges. Some of the notable challenges include: 1. Data quality and quantity. The quality and quantity of data available can significantly impact the effectiveness of data science projects. Incomplete or biased datasets can lead to inaccurate models and unreliable insights. 2. Interdisciplinary collaboration. Successful data science projects often require collaboration between data scientists, domain experts, and business stakeholders. Bridging the communication gap between these diverse groups can be challenging. 3. Ethical concerns. As data science becomes more prevalent, ethical concerns surrounding privacy, bias, and transparency have gained prominence. Ensuring that data science applications are ethical and fair is crucial for maintaining public trust. 4. Continuous learning. The field of data science is constantly evolving, with new techniques, algorithms, and tools emerging regularly. Staying up to date with the latest advancements is essential for maintaining relevance in the field. 5. Model interpretability. As machine learning models become more complex, understanding and interpreting their decisions become challenging. Ensuring the interpretability of models is crucial, especially in sensitive applications like healthcare and finance. Conclusion. In conclusion, a career in data science opens doors to a world of opportunities. With the increasing reliance on data-driven decision-making, the demand for skilled data scientists is unlikely to wane. The dynamic nature of the field, coupled with its applications across diverse industries, makes it an exciting and rewarding career choice. To embark on a successful data science career, aspiring professionals should focus on developing a strong foundation in programming, statistics, and machine learning. Additionally, cultivating effective communication skills and staying abreast of industry trends and advancements are key to thriving in this ever-evolving field. As technology continues to advance and data becomes more ubiquitous, the role of data scientists will remain pivotal in unlocking the potential of information. The journey into the world of data science is not just a career choice, it's an exploration into the realms of possibility, innovation, and transformation. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding!